Okay, great. Thank you very much. So, good afternoon, good evening, good morning, everybody. As I broadcast you from the middle of Canada, early Tuesday morning, I really wanted to share something I'm very passionate about, as I have been flying around the world and chatting with many customers or clients around improving their DevOps capabilities. And what I often hear is so many times people start off with automating a practice without looking at the process behind that practice. And by that I mean, and we'll get into it throughout the session, is organizations typically have rules and constraints in place to deal with certain things that have happened in the past. And simply automating that process will not help companies achieve their true potential. So I want to go back to the foundation a little bit, and I really like this statement from Damon, where DevOps is not about technology, DevOps is about fixing a business problem, and we really need to focus on that. One of the things I hear from many organizations is there's a disconnect between the engineering teams and the business teams, in that the business has certain expectations, and perhaps engineering isn't delivering the functionality they're looking for, isn't delivering it as quickly as the business needs it. And really, we need to look at what is the business trying to achieve. And businesses, the ones I've talked to, what's keeping the CEO level or the C level awake at night is with respect to delivering business results. How can I increase my revenue? How can I increase my share value in the market? How do I lower the cost? How do I reduce expenses and improve my expense to revenue ratios? How do I make sure that the customers that we are delivering functionality and features to through software are happy? Are we delivering the functionality that they need to do their jobs? And within that, when I talk about customers, everybody is a customer, internally and externally. So if I look at the delivery pipeline, the business is a customer of engineering. And then within the engineering group, the developers are customers of analysts, and the testers are customers of the developers, and so forth. So there's that whole feedback loop. And then the last item that businesses are really looking at is making sure that they are secure and compliant with industry standards. So one of the biggest foundations within DevOps is establishing trust, having a shared vision across the organization about what are we trying to achieve as a business, and how do we build trust across all the groups that make up the business. And by that I mean the business leaders, the management team, developers, testers, operations, the security and compliance organization, right down to the consumer. This is very important, because this is the foundation. I've chatted with some, and when I look at from a quality point of view, when bad things happen to good people, when a production incident escapes into the hands of the consumer, what is the first step that somebody may take? And quite often it could be finger pointing. It could be trying to blame somebody. Well, that's not really building up trust. We have to believe that we are working towards the same goal, and we trust that everybody is going to do their job to the best of their ability. I've yet to come across anybody who's been truly malicious in trying to disrupt this overall flow. Now, within this foundation of trust, we're really focusing on culture to achieve that corporate mission. And by aligning to the business, that's why it's important to have a DevOps strategy and make sure that everybody understands how they commit to delivering against that strategy, how are they measured, the shared outcomes, and structure ourselves where we have the type of behavior we're looking for, as well as collaboration. Below that, we look at the foundations. How are we going to measure progress? This is very important in reporting up to the business as to, are we achieving our objectives? Are we going to be able to deliver faster, or are we be able to lower our costs? How are we measuring that? And then to the left and right, we put guardrails in place. We'll typically implement some automated solution that will help us perform one of the practice areas consistently, reliably, and repeatedly. And we also have guardrails in place where we deal with lean process. We're looking at this pipeline from end to end to identify where there's sources of waste and how are we going to remove them. And that's really what I'm going to focus on in this talk. So as we look towards aligning the business and IT, and we do this in a workshop with different organizations to help them prioritize where to spend their money with respect to engineering. So if I look at some of the business objectives, and these are just samples, but I like to look for qualified and quantified objectives, meaning that maybe a business's objective is to release new features 25% faster over the next 6 months so that we can increase market share or improve our street price. Maybe we want to reduce internal IT costs by 15% in the next 12 months to reduce our ER ratio by 3% over the full year. Maybe we want to increase customer satisfaction by improving uptime to 99.5% and decrease production incidents by 10%. These are all quantified business objectives that would contribute back to, again, a revenue, ER ratio, delighted customers, and I don't have one for security and compliance in here, but it's, we could have many, many business objectives. Underneath that, what are our information technology or our engineering objectives? Well, we want to increase our deployment capacity leveraging automation. We want to improve our testing efficiency through automated test execution and by testing earlier. We want to transform and refactor legacy applications. And we start to get some linkages between the business objectives and the technology objectives in helping to achieve. So if we look at the business objective as a hypothesis, and then the information and IT objectives as experiments, or even better yet, technical initiatives, which could be experiments. Things we're going to try and measure to see if they will help achieve the business objectives. So maybe we're going to re-architect our applications and go to microservices. Maybe we're going to implement a deployment automation solution. Maybe we're going to start using containers and deploying to Kubernetes and cloud. Maybe we're going to implement test automation, including service virtualization. Maybe we're going to adopt the 12-factor approach to development. These are all the initiatives that are feeding into the objectives, which roll up into the business objectives. And this is very important because the business objectives are the things we're trying to achieve in supporting the business stakeholders, as well as eliminating that disconnect between the business and engineering. Now, let's not forget about the three ways within DevOps. We have multiple practice areas. We have continuous integration in there. We have continuous delivery. We have continuous testing. We have continuous availability. Those are individual practices that I see many organizations will typically try to automate. Like the deployment automation solution would help me support the continuous delivery practice. A test automation solution would help me support a continuous testing practice. If you just focus on those individual practice areas, you could be creating automation silos within the value stream, meaning that there could be a slow point ahead of that practice improvement, or there could be a slow point after that practice improvement. So it's really important that we focus on optimizing the system as a whole. Looking at how do we take that idea, that new feature function that the business feels is important and is tied to the business objective, and how do we get that into the hands of the consumer as quickly as possible? And the reason we want to do that is so we can close the feedback loop. Did we hit the mark? Did we meet the needs of the end user by providing them with these updates? And we do this through a whole process of continuous learning, experimentation, improvement. We're basically questioning how we do things. We're looking at the process and starting to ask ourselves, why are we doing this? Is there value in doing that particular step? And if I look at Goldratt, in his book, The Goal, he's called out that every organization has at any given point in time at least one constraint which limits the system's performance relative to its goal. So that's why it's so important to look end to end. And when you find that one constraint and you address it, you want to revisit that pipeline because there's going to be another one. There's this, I've actually heard people say that, yeah, we're done DevOps, we're finished. There's been an evolution in software development for years. We've tried multiple methodologies, waterfall, iterative, agile, up to a DevOps methodology now, where we are on this journey of trying to continuously improve. And we keep expanding the scope. In DevOps, we're dealing with the operation. We've brought the operations side in, we've brought the compliance side, and we've brought the auditors in, we've brought the SREs in. This is, again, the next step in achieving this goal of an optimized pipeline from end to end. And we've been doing this while, for many years, these limitations still exist. If I look across that pipeline from ideation to implementation or backlog to release, I still see things like, or I hear from clients as I execute these workshops, we have a lack of visibility and traceability across our work items. How is my work connected to somebody else's? There's complexity and change. The scope of a sprint or a release is so large that we just physically cannot get that change into production fast enough. It's just too complex. Maybe we decrease the scope of change. We also suffer from scope creep. There's 4 types of work in a DevOps world. There's the business work. There is internal work, where things we have to do. Address technical debt could be one example. There's updates that we need to apply to a system to remain compliant. And then there's the unplanned work, the stuff that just kind of shows up. And this could be considered scope creep, but it's also a form of interruption, which is slowing down our ability to, turn idea into code and release it. And one of the places a lot of organizations could start in optimizing their processes, understand the impact of these interruptions. How much time is being spent on addressing things like, how often does somebody go to their email? How often are they dealing with instant messaging? The walk-up types of conversations, along with this unplanned work that arrives into their queue of activities assigned to them. I talked about trust, but we still see a lack of requirements, well-documented, well-articulated requirements that truly define what the business need is. A lack of access to documented design access, a lack of collaboration. A lot of organizations, the application architecture is relative to how they are structured within their organization. What are the lines of communication? If we have multiple lines of business and they're not talking to one another, we could be writing the same functionality in multiple applications rather than create one service application that all these other applications simply call. So we've got an increase of effort around development. We're almost overproducing, which is one of the sources of waste. When we start to look at the repeatable side of the process, many organizations could still be doing manual deployments. They may have environment inconsistencies, meaning that their dev environments aren't configured the same as their multiple QA environments, which is slightly different than their production environments, which means that their deployment activities and their configuration activities take longer. There could be long lead times. It's well documented that a lot of waste could reside in manual queues that are making up this development pipeline. For example, I was speaking with one client that they have to walk a document around the floor to about 6 or 7 different stakeholders to physically get a sign-off in order to release the application. Well, there's a lot of wasted time in just moving that document around. They're not using email. It's a physical document that people have to sign. Excessively long time that's going to impact our ability to deliver. Hopefully not of a lot of organizations are still having to submit a ticket to a build queue, but again, another form of waste. Testing dependencies. I have to wait for one team to finish their work before I start my work. I don't have test labs, and we'll look at that a little bit later on. A lot of manual testing still going on, environment scheduling conflicts. And when we look at all these limitations while we work under these pressures to, deliver in 2-week sprints or release in 3 months quarterly release cycles, we're missing the expectations of the business. We could be running late and releasing delays, or we could have poor quality within our application. Now, as we start to look at the queue, if we look at one thing, let's focus on dealing with what is the cost of delay. How long are these queues taking? Because time is truly money. And if we look at the cost of delay, if we look at a pipeline in the middle there, from capture to proof of concept to go live, and we do a whole bunch of filling our backlog with ideas, and then there's a waiting time before those ideas become part of a sprint plan where we start working on something. Well, there could be a delay between the proof of concept or the beta of this application or these features until we actually get into formal dev test and then go live. We're looking at 38 weeks waiting in this example. Well, what is the cost? One of the business objectives was that expense to revenue. Well, if we got rid of that waste and we could save, N number of dollars per week, that is off the expense cost, which is going to improve our ER ratio. And it's these kinds of visibility into truly understanding how long an idea takes from the time of inception until the time of implementation will influence our decision making. Maybe we apply more people. Maybe we de-scope some work to help accelerate that delivery. Either, sometimes you can put more money at a project in order to implement a little sooner, but you also have to balance that off against, if we throw too many resources at a project, we now get into that mythical man concept of too many people actually takes longer to complete a task. And then, let's focus on the value and speed when we're prioritizing things. The 80-20 rule comes into play. What is going to deliver the most amount of value with the least amount of effort? And talk about minimal business increments, or maybe you may have heard it as minimal viable product. We want to get something into the hands of the consumer as quickly as possible so that we can rate it or understand, did we hit the mark? Are we close? Do we need to pivot? Is there additional work that we need to do to improve this? But that all comes back by, again, accelerating the delivery of the idea in the form of software to get that feedback from the end user. And if I look at GoldRat and the goal, there's really an optimization framework. So it's identify that value. What is of high importance to the customer? And then understand how that value goes through the pipeline from ideation to implementation to look for the slow spots, look for the constraints, look for ideas on how we're going to fix or remediate that particular slow spot. Then we work towards creating a smooth flow and then the right amount of pull, where as the developers or the programmers finish up a piece of work, they're able to pull from a queue continuously so that we are not interrupting flow. I've seen situations where a whole bunch of work is moved into in progress, which exceeds the cognitive capacity of the development team. We want to have the right amount of work in that particular stage so that the developers and the programmers and the testers have the space or the bandwidth to complete those tasks in a timely manner. And that's where I was talking about the unplanned work. So often, if I look at a pipeline, you'll have your backlog and you'll have a design and then you'll have your sprint plan, and a collection of work items that will be queued up for development. And the developers will start to pull from that queue into their in progress stage. And then some unplanned work will come in and enter that stage, not going through the standardized process of backlog and then prioritization assigned to a sprint plan and development work, but more it's just injected into the process at the in progress, which is creating an excessive amount of work, which you may, if you're monitoring work in progress, you may see that as you've clipped the work in progress threshold. That work in progress threshold is really giving an indication of how many work items or how many points a team can deal with at that particular stage. And then as we move along, seeking perfection. We're not done DevOps. It's a journey. It's a marathon. You know, you've probably heard this many times. DevOps is not a sprint. It's a marathon. It truly is, because, you know, since inception of IT and software development, we have been on this journey of continuous improvement, which is within one of the three ways within the DevOps approach. So we need to look at all of this, right from the line of business and how do these new ideas enter the process, what are all the steps that they go through, and it's going to be different in every organization. How long does a task take? What is the in progress time versus what is the wait time? What are the artifacts that we are creating? Do these artifacts deliver value? This is basic lean to try to find where sources of waste are and eliminate them. So it's important to focus on the value stream end to end. And if we look at left of the commit, so if we consider that the developer is going to write some code and commit some code, the agile development lean side is very much the creative side of the process. It's hard. You know, it's going to come down to a maturity of how do I estimate particular stories? What is my team's burn rate? How many work items can they put through this process? And when we look at the left or the right-hand side of the post-commit activities, this is very much the repeatable, the optimizable, the things that we can automate. So to the left of the commit, the creative, the human aspect, the cognitive capacity of the team, the skill level of the team, the structure of the team, the organization of the team. And on the post-commit, well, we know that there's solutions out there that there could be a webhook. On the commit of a piece of source code, the build is automatically triggered. The unit tests are included inside of that build. Maybe some security scans are run as part of that build process. From there, it's deployed into a test environment where a series of tests are run. And maybe then if those tests are all passed and the deployment is successful, we go to another environment where we run some security scans or we do some performance testing up until the point where we get to release automation. And this is, you know, the difference between continuous delivery and continuous deployment. Continuous delivery is we could commit and go through all of these different stages on the right-hand side up to release. And then we're going to have some level of manual intervention. Maybe it's a change control board, maybe it's user acceptance testing, and we will make an educated decision on whether we are going to push to production or not. Continuous deployment is from the commit of that source code change, the build will occur, the deployments will occur, a series of tests will be executed, some scans will be done, and it will automatically be released into the production environment. But we've got to look at it holistically. So you'll hear stuff coming up around value stream management, the latest thing, the DevOps Day 2, where we're looking at the idea through to the consumer. And if you really think about it, value is not realized until after the consumer has had a chance to use the functionality and establish an opinion on whether they got value and what type of feedback or what new features and functions do they need next time. So we want to track beyond that so that we can really trace the idea through to the end customer. And the feedback may be, you know, back to the business objectives. Because we did this faster, perhaps we increased our market share. Because we did this faster, perhaps we lowered the costs and improved our ER ratio. If we did this faster and shortened up the pipeline and got new features and functions to the consumer, perhaps we're going to have more satisfied customers using our software. Now, again, these various stages like plan, design, develop, build, deploy, test, secure, and release, they may vary by different organizations. So I'm going to spend a little time on building this out so that you could run this in your organization, or you could invite us to work with you. And so what we're going to look at is, what are these cues? I talked about understanding these invisible cues. Where's their wait time? Well, an idea comes into planning. Is there a wait time before that? As it goes from plan and design, is there a wait time? As design to develop, and you understand, you can see the repetition. Within each one of the stages, we want to look at the in-process time. So what is the overall time? It could be a week. What is the active time? Well, the interruptions and the emails and the meetings and the phone calls, of that 5 days in process time, I'm probably spending 2 days in active time. And then the percentage of rework, how much change, how much churn happens with my activity? You know, are there improvements? Are there updates? Are there modifications? Are there change requests associated to it? What is that percentage of rework? And then I like to have a sense of what tooling is being used at that stage. There's a lot of great tools out there. Sometimes it could be the tooling is used inappropriately. Sometimes it's just the wrong tool. So we want to look at things like that. And what does this do? What this activity? And you know, I want to bring in leaders from across my organization. So I want to bring in my app dev managers. I want to bring in my senior technical people. I want to bring in representation of that pipeline. And I'm not talking, you know, 60 people. I'm talking the 10 key people, the subject matter experts, the leaders in their various disciplines come to a table and they have this discussion. And we often hear that this is the first time organizations have done this, to truly understand the handoffs and the type of work that everybody does. We hear things like, let's say for testing and planning, you know, I have to create this really, really big test plan. And the others at the table may go, yeah, we've often wondered why you do that, why you give us 50 pages where 49 of them we don't read. Well, that's waste. That's overproduction where there's little value back to the activity. We want to understand how these flow of ideas across the team. And when we get to the end of this exercise, we have a measured baseline on our current DevOps capability, our as-is state. You know, one of my roles as a performance tester, I always had a benchmark, and then I would make a system configuration change, run some tests, and then do a quick evaluation. Am I better? Am I same? Am I worse? So now we're getting into the measuring side. So this workshop, this value stream mapping exercise, is really understanding the as-is state relative to time to identify where waste is. And that gives you the foundation to measure improvements as we've pinpointed areas of work and we identify and prioritize where we're going to implement a change that delivers on our business objectives. So one of the templates I use an application called Mural. And Mural in this world of COVID, you know, we used to do these activities face to face. It was really great to get everybody in a room, those key stakeholders and those key technical experts in a room to have this discussion. And you could read body language and you could, you know, diffuse any arguments or discussions. You could facilitate a lot easier. But those days are somewhat behind us. And hopefully they return, but we'll find out. It's more important to keep everybody safe. So things like Mural, M-U-R-A-L, or Miro, M-I-R-O, are highly collaborative whiteboard tools where I can have these same individuals that I would have in a room actively participating in an exercise where we are going to fill out this value stream map. And again, it could vary. The stages could vary depending on what stages you have in your organization. So let's take a little bit of a look at this. So here are the main stages that make up my sample pipeline, and yours may be different. This is something you're going to want to understand. What is every stage from the idea being entered into the backlog until that idea is out into the hands of the consumer. Then we're going to inject wait times in between, or a wait time indicator in between each one of these stages so that we can capture that. The next thing we want to look at is under each one of those stages, what is the total time spent on that particular activity, and what is the percentage of rework that we would spend on that activity? The next thing we want to look at is what are the activities that role type will typically perform. And not everybody does this. I like to get an understanding of the main activities in case there is waste inside of there. And we'll do a sample, we'll walk through this, and so you can see things that I may be looking for as we run these workshops. And then the last part is what kind of tools are they using? So let's put on a developer hat for a moment and let's start to make some updates. So if we look at, from design to dev, let's say something sits in a queue for 3 days. So we enter that. All we're doing is collecting information from the team. And then how much time do I typically spend in development? Well, if my sprint is, say, 2 weeks, which is we're going to be building and providing a deployable component, and of that time, we've got to do some development, we've got to do some build, we've got to do some testing, and then we've got a releasable artifact. Let's say that I'm going to give this 7 days. And then how much rework? How do I change my code? How often once I've done that final commit, how often, what percentage of times are defects surfacing? When do they surface, and how do I get feedback on them? I'm a really good programmer, so I'm going to say 5% of my code I have to do a tweak later on. And what kind of tools am I using? Well, let's say I use Jira for work item management. Let's say I'm using Eclipse for my IDE as I'm developing Java. And let's say I am using GitHub for my version control system. That's enough. And then we're going to look at our activities. And the nice thing about Mural and the collaborative nature of it is this can all happen simultaneously. If we have somebody representing planning or design or dev and build, they can all be filling in this data at the same time. Again, it's a highly collaborative environment. But if we look at our activities, so what do? We clone the repo. And then we make code changes. And then we commit and merge. We do some testing. Maybe we run a security scan on our source code. And then we request a build. Okay. Now, what happens on the build? So we request a build, and maybe it sits in a queue for 3 days. Now let's make it 2 days. Our build portion's on top of the job. And the total time is, well, they have to update some build scripts, and then they have to execute the build, and if the build fails, they may have to triage. So let's say it's 2 days of effort here. And our percentage of rework, our builds are fairly accurate, so let's say 10%. they run quickly anyways, and we're using, from our tooling point of view, we got Jenkins as our build management and just some Ant scripts. What do we do on our activities? We address merge conflicts. We update build scripts. We execute build. And we notify of outcomes. And maybe we, maybe we don't have a continuous integration to a continuous deployment. So our build becomes available, and now we have to deploy. So we're going to say 1 day here, and our total time to deploy into a early test environment is half a day. And you kind of get the picture of where I'm going here. It's truly understanding all the activities that are happening as we go through this process. And we're going to get a really good look at what that end-to-end process is. If I quickly looked at this and the samples that we put in here, design to dev, well, are we overproducing on design? Are we spending a lot of time? Or why can't we increase our pull? Why can't we drop this down? Or as design happens, include the developer in the design process so that we can eliminate that 3-day handoff? Because something could change in those 3 days. If we implemented a continuous integration solution on the commit of that source code, and we have a mature branching strategy in our version control system, even committing right to trunk, maybe we can eliminate that 2-day wait time between the dev and the build teams, where it is seamless. The commit triggers a webhook which fires the build process, which does some unit testing, which does some security scanning, and automatically promotes it into an environment or a build repository where the deploy process can automatically kick off. So had we just gone in, and I said at the start, automation tools don't fix bad processes, we could have build automation, but if we have a queue in front of it where somebody has to submit a build ticket, and we have a queue after it where there's going to be a lag between the build artifact being available and a release team deploying that build artifact into an environment, there's 2 sources of waste right there that we could eliminate. And one of the really interesting things, I always ask, what is your release cycle? And the answer I always hear is it depends. We try to release quarterly, but if there's an emergency bug fix, well, we can do that in 2 days. So we're trying to, how can you go from 2 days to 3 months? Well, it comes down to the complexity, the scope of change for a particular release. What if we looked at smaller release cycles? Maybe there's too much governance in place where we have all these rules and limitations that is slowing us down. So again, that's where we're trying to get to. So hopefully you get a sense of how you can build this out in your organization, figure out what your stages are in your pipeline, understand the wait time between each one of those stages, understand the total time spent on that particular stage, how much rework is actually happening at each one of these stages, and then what are some of the typical activities that you will start to get hints on where you are in your maturity level. So if we come back to the slides, here's an example of something that I mocked up to try to articulate this a little bit more. The release cycle here is in greater than quarterly. If I look at things very quickly, I can look across the top and say, okay, there's a 10-day lag between user acceptance testing being completed and the release actually happening. What is going on in that stage? And we could go a little bit deeper, but we want to look at a macro level across all of these different activities. We want to get a big picture. Perfection, we're not looking for perfection. We're looking for estimated guesses, the best that we can possibly get. We don't want to spend a lot of time on this, and we don't want to drill into each one of these activities and waste time because we're overproducing. So again, having this macro view of the as-is state, I can see that there's an excessive weight between, say, the UAT testing and the ability to deploy code. I can also see that, you know, I have a percentage of rework in the final testing stage of 65%, meaning that we've got some late stage defects coming into the system. You know, what could we do to possibly improve the level of quality so that we're not doing defect discovery late quality stage, we're doing functionality validation. And it's very different. We all know that the later in the process you find defects, the more expensive they are to fix. I can also look back at the development organization and say, well, they've only got 2% rework. So what is the other stuff? Is it configuration issues within the deployment of the infrastructure? So we're going to dive deeper into that one. Or it could be a look at, you know, what tools are they using? Well, obviously, if they're using Word and Excel, they're highly manual. What kind of improvements can we make to address those types of challenges or things that are slow? So again, this gives you that high-level vision as to where you are in your current state on your deployment capabilities. And again, it's understand your stages. Everybody's stages are going to be different. Everybody may have a different number of quality check environments. You know, what is the total time you spend? What are the types of things that you do? What is the percentage of rework that you experience? What tools are you using? But really importantly is, what is the wait time between each one of these stages? Because those are the invisible queues which can end up costing a lot of money. So let's drill into this 6 weeks. So once we've got our macro view and we've said, okay, if we're going to do one thing, the big idea to fix this problem, we're going to focus in on improving our final QA stage and particularly addressing that 6 weeks of execution time in UAT. Then I'll switch to a micro level, and this may be a follow-up activity once you've got an idea as to where you are in your maturity levels. So, you know, if I look at this and I start to, again, go to that next level of process time, in-process time, wait time, and rework, as I looked at the activities the test team was performing, they have to request an environment. And then that environment takes 5 days. They have to create test data. They have to update their test assets. They have to maybe work with DBAs or the test leads or somebody to reset their test data. They have to work with the release engineers to deploy those applications. And then they're going to finally execute their tests. When they're done, they're going to have to compile their results. So if we looked at the micro view of just the activities that happen in that final test stage, we can see that we spend 5 days provisioning a test lab and 5 weeks executing tests. Why is that? Well, then you may go as far as creating the process flow, understanding truly what are the limitations and constraints in this process. And as I talk to different organizations, one of the things I'll hear about is, and I'll use this process as an example. Okay, so the first step a QA has to do is reserve an environment. So they have to check an environment to see if one's available on those dates. Why do they have to do that? Well, one, there's probably not enough infrastructure in order to create an environment, or two, there's a rule in place because back in 1975, somebody deployed an application change into an active test environment and clobbered the other team's work. So we put a rule there so that that doesn't happen again. And then what is the constraint we put in place? Well, if the rule isn't satisfied, we have to send an email to the infrastructure team to provision an environment, or we have to send an email. If an environment is available, we send an email to the release management team. Why do we do that? Because we don't trust the QA team can accurately deploy that application as if they would deploy it in production. They would take some shortcuts, potentially. Or why do we have to send a note to the infrastructure team? The QA team doesn't have the skills to provision an environment accurately. So we've put 2 tickets off to different other groups as we're preparing our tests, and we're going to wait until that environment becomes available. And when it does become available, we're going to execute some tests and send some verdicts. So if we keep looking at this, there's a framework here. We want to understand what the technology does, what limit or what limitation are we going to eliminate, what rules do we currently follow to accommodate this limitation, and then we start mapping out what is the best way we are going to proceed forward to optimize this particular stage as we work to deliver on the business objective of improving our test efficiency. And if we improve our test efficiency, we're contributing to the business objective of lowering our expense costs to deliver and improving our, our revenue, higher quality. So our limitations are, we got lack of test environments, we have a lack of available infrastructure, we have a lack of trust across our teams, and we have a lack of integration in our automation, where perhaps that automation infrastructure could be automatically provisioned and the application could be automatically deployed. And I start to highlight these out. What are the things we're going to focus in on automation? Well, if we look at this, we can enable monitoring as part of our deployment. We can deploy our application through automation. The provisioning of infrastructure, there may be some manual configuration steps, but we can automate a lot of it. And as we execute our tests, if it's a regression test, we could automate a large percentage of it, but there may be still some tests that we're going to run, some exploratory tests. Automation tests aren't the silver bullet. They can't think. They're robots. They do what they're instructed to do, and they do it very well. They don't get tired. They don't go for coffee. They don't have sick days, but they can't think. And so many of the applications we're looking at from the user perspective, the user experience, you need a human mind to be exercising the application and understand, does this make sense? Is this going to help solve the problem that we're hearing from our customers? So there is some opportunity for automation. In this case, we're going to focus on better test execution, but we also have to look at provisioning the environments and deploying the application. And I have operations in here because I'm a big fan of shift operations left. When we talk about the trust factor, if we think of how some organizations work, maybe the test and the development team are working together. They're doing pair programming, test-driven development. But when we get ready to deploy to production, perhaps this is the first time operations has seen this application. And there could be a delay, and they want to understand, is it stable? They're going to run their own tests to make sure that it is secure. They're going to make sure that it adheres to corporate standards. There's a plethora of delays that could appear at this time. So in the shift left operations model, we're bringing operations in right from the start. They have visibility into the work that's being done. They have activities on the Kanban board. They understand their role in this process. They have monitors on each one of the test environments en route to production, so that they know the application is stable, or they know the application will scale and it's reliable as they ramp up on this route to production. So I always believe that it's important to include the monitoring team and enabling the operations team and enabling monitoring in the early test environments, because it's going to build up trust between this dev and ops and break down that silo. And then when we get to it is, what is the to-be way we're going to work on things going forward? And I've talked to some customers that actually have this in place. They've made the move to cloud, at least for dev test environments. Their QA teams have the ability to kick off that process, that ability to perform a test environment where, the press of their go button, it will automatically provision a cloud instance. It will automatically deploy that application into a cloud instance. Monitoring will be enabled as part of the deployment process. Yes, there's going to be some automated tests, but as those automated tests are running in the background, teams can be doing those exploratory tests or some validation tests, or tests that require a human mind to look at the application and verify, or to think and to check the functionality from the end user experience. And then when we're done, we're going to decommission the cloud environment. Now, I talked about trust is a very important part of this entire process. So how do we build up trust and eliminate that constraint where we have to make an email request to the infrastructure team? Well, if the infrastructure team knows what's being built and they're included at the start, perhaps they can create Terraform configurations or configuration scripts using Puppet or Chef that would allow them to provision that cloud instance. Perhaps they have VMware images that could be provisioned into a cloud environment, depending on their application architecture. But these are approved configurations that have been built by the infrastructures team, so how can they not trust? It's their work that's being used to instantiate that environment. As part of that, we have integration between the automated configuration to the deployment process. The deployment process that has been written by the release engineers that understand how to deploy that application. So now the QA presses the button, the environment's provisioned, the bits are deployed into a test environment, the monitors are turned on. So now, you know, how did we turn on the monitors? We use the configuration scripts from the operations teams so that they're getting the data back on the application that they need to make that decision when they're asked about, okay, we're done our testing, we're satisfied, let's go live. Give it to the operations team, and that's where that bottleneck came into play. Well, let's use their stuff and provide that information to the operations staff through the development process. And then we're going to execute our tests. Well, the QAs wrote those tests, and then when we're done, we tear down the environment. So what business objectives did we hit here? Well, we delivered at least through this stage of the environment a little bit faster and took that 6 weeks down to maybe a day or a couple of days. We've started to embrace cloud technologies where we haven't had to purchase a lot of infrastructure that is sitting there idle for a large percentage of the time or underutilized in the off hours. We are moving from a CapEx to an OpEx financial model where we're just going to pay for the services that we consume from the cloud provider, and when we're done, we're going to turn it off. So we've lowered the cost of IT. We've increased our test efficiency by at least moving towards test automation, and you know, this could become the foundation for where we're going to go next. If we look back at the value stream map, maybe the next environment is an earlier test environment. Maybe we, you know, as part of the testing, we start to use virtual services or stubs to simulate dependencies so we can shift our testing left as well. You know, we're going to this is the first step, and that's when I talked about the better, same, worse. This is a measured improvement. We can demonstrate to the business. We've run a few experiments to support the hypotheses on these business objectives, and we can measure this value, and we can show that, okay, our QA stage and late UAT, it's gone from 6 weeks and now we're down to 3 days, which is a massive savings when you look at the cost associated to building software. Now, as I talked about, you know, the value stream map gives me my benchmark. I've prioritized an opportunity where I'm going to optimize. We're going to identify the solution, understand the limitations and constraints, and how is that solution going to address those. We've got our measures, so we're going to be capturing, is this contributing back to the business, and we're going to tweak. We're going to optimize, optimize, optimize. We're going to continue to optimize until we feel that we've addressed the majority of the bottlenecks, and now we're just in for small changes where we move to management. Now, there's two ways you could look at this. You could do a value stream mapping exercise and then get an as-is view of the environment. You may look at a value stream management solution, which will start to pull data from queues like Jira and Git and ServiceNow and test automation solutions and deployment automation solutions that will allow you to understand where the slow spots are in your organization. So you could take one of two approaches: do a value stream mapping on a journey to value stream management, or implement a value stream management solution that's going to start giving you data on day one to make better decisions. So a value stream management solution, we talked about hidden queues, invisible queues. A lot of the information that organizations need is already readily available to them. You know, Jira is a very popular planning tool. GitHub or GitLab are very popular version control, or you know, they offer flow solutions as well. There's a variety of build repositories. There's a variety of deployment automation solutions. There's a variety of testing solutions. There's a variety of change management solutions, a variety of different application performance management solutions. So if you implemented a value stream management solution, you would start pulling in data from all these different queues. And you could look at all of them individually and try to formulate this, or you could bring them all together into one dashboard that would allow you to make better decisions. And if I look from left to right, you know, I can see in my backlog, I have, say, 15 work items, and they're traditionally sitting there for a month's time. The backlog where we've got some points, there's 6 work items, and they traditionally sit there for a week. Or the production incidents, you know, there's 12 of them, they sit there for a month. Production incidents sit there for a week. In progress, so this has been the pull. The developers have pulled these work items into the process, and you know, our work in progress limit is 5, but we currently have 7 work items in this particular stage. Maybe this is an artificial bottleneck. Maybe this is 2 of these work items of this unplanned work that I talked about that have just appeared without going through the process. How do you find those types of things? How do you bring all this data together so that you can make those accurate decisions? Another common slow spot that I would hear about is, as part of the process, the developer commits, and then they have to issue a pull request to have somebody review their code change. The pull request queue could be very much unmanaged because people may not have visibility into it. So if I look down here in the review stage, maybe I can, the value stream management solution highlights which ones are running slow, which ones need my attention. I can look at, you know, what is the work item distribution across my team? Perhaps I've assigned too many tasks to one individual and I've exceeded their cognitive capacity, where I could distribute the work across to others. So again, you could start with mapping, where you get a picture of the environment, not looking at, say, where things are backed up in the queue, but it's a swag on where potentially the slow spots are. Or you could look at a value stream management solution where you start capturing data from day one, and it will present to you where these slow spots are. If I looked at this, you know, I'm looking at my slow spot. Well, I've got an issue in progress because I've exceeded my capacity. Maybe I could do a little bit better on grooming my backlog because I'm running at a month there. I'm not concerned about, you know, QA to production. Here are QAs at 1 week. Maybe I could do something there. And what's really interesting is some of these value stream management solutions will allow you to do some hypothesis. What if we pulled this work item out of the stream? What would be the impact? Could we release sooner? Or it could be, there's some that have artificial intelligence that use business rules to do calculation on slow spots. So is there an imbalance of flow? Because what we're trying to do is the idea comes into the process, goes through in an unimpeded flow en route to production. Is there a particular stage where there's kind of a rush, where our team's doing batching, where they take a whole bunch of items from the backlog and they put them into, you know, selected for development, and then it quickly goes through some stuff, and then we wait for everything to get to dev before we deploy to a QA environment, and then when the QA is all done, Then we deploy to the next QA environment where we're batch releasing our work items across the flow. Very difficult to detect, but a value stream management solution could help you with that. You know, if there's others way around slow stages, how much time is each one of these work items traditionally spending on average in each one of these stages, and is there a stage that is collectively slower than all other stages? So what this kind of a dashboard will do is gives you the data to have a conversation. It's to understand where those bottlenecks are, and then talk to individuals or talk as a team to understand, you know, okay, we have a limitation. What technology is available to help us solve that limitation? What are we going to do to improve that limitation, and how do we measure it? And you know, we can look at some of the DORA measures on lead time, cycle time, throughput, distribution, but we can also get into contributors and the load across the workload distribution. You know, how many points is a particular individual contributing? Now, that may be an unfair measure, or if you tell somebody how they're being measured, they may game the system by implementing buffers to try to make their measures look better, particularly if they're being compensated based on their performance. So watch some of these, but from an app dev management point of view, or from a business stakeholder, how is IT helping business achieve the objectives? Well, you know, if we look at our lead time is typically defined from when something enters the backlog as an idea until it enters the production environment. Cycle time is traditionally from the time that something is selected for development or becomes part of the sprint and is actively being worked on until it enters production. So if we, again, reflect back on the business objectives, we want to be able to deploy faster. We want to reduce our costs. We want to increase some efficiencies. Well, by providing this dashboard to my business stakeholders, I can see that, you know, my lead time, we're doing a lot better. My cycle time is down. My deployment counts, you know, they're up, but maybe my failures are way down, so I've got an improvement there. We're tracking all of this information. Our unit test coverage is up. Our functional test coverage by line is up. We can pull data on security statistics. So this is the measuring part of it. So if I go back to the 4 principles, culturally, we have to understand what we're going to do and organize for success and truly understand how we contribute to the business objectives. We're going to measure on our improvement, and it may be very, very small baby steps. You know, I would not suggest that when we get to a world of you know, we found 5 opportunities to optimize, let's do them all at once. No, pick the priority one. Pick the one that's going to give you the most return on your investment, so that you can demonstrate to the business, because it's the business who releases the funds that allow you to continue to move forward. And having dashboards like this goes a long way in communicating that value to the business. And these are proven that if you start to manage your value stream and truly understand how your value stream is working, you'll see a return on investment around culture. You know, I've heard many organizations try to define DevOps, and early on in you know, 5-6 years ago, you know, people would ask me, what's your definition of DevOps? I've really simplified it. Happier people delivering better software faster to support the business. It's pretty simple. Culturally, we all want to be happy in our job. We want to do things that make sense. We want to be efficient. We want to be productive. We want to feel like we're contributing. We want to do it without waste. You know, how many on this session, you know, how many are sitting there going, you know, there's steps in the process that I do every day that I have no idea why I do them. It's okay to question in this world of trust and open dialogue and a fearless environment. It's okay to ask why, because that may be a source of waste that is going to help contribute to the business objective. And the automation and the operations stuff, Again, it's all positive trends in moving towards just managing the value stream. Now, within our organization, HCL Software, we offer these types of workshops, and we look at 3 areas of improvement as we look at process optimization and finding the slow spots, and then recommending change to make an improvement. And it looks at ways of aligning. So that's very much cultural. How are we structured? How are our teams set up? What are our business objectives? Do we share those? How are we celebrating successes? Ways of working. These are processes, you know, focused in on building trust, embracing change, sharing experience, continually questioning and working to improve our day-to-day jobs and the tasks that we follow. And then there's ways of automating, where there be continuous integration, continuous delivery, release orchestration, continuous testing, scanning, or monitoring. All of these are geared towards, the 3 legs of DevOps: the people, process, and tooling. And to just focus on tooling, in my opinion, is a mistake. Cultural change is critical. Process optimization. If you don't fix the process, the automation tools will show some value, but you're just going to automate inefficiency and do things wasteful things that you're going to do them consistently and reliably and repeatedly. And then what we do as part of our workshop is working with the client and you would want to do this if you chose to go on tackle this workshop mapping exercise on your own, is understand the feasibility of and the importance of each task. And this will help you in prioritizing. What is something that we could do in 3 months that's going to give us a significant return on investment? And maybe we just have to better align for our desired outcomes. Maybe we need to understand what the business objectives are so we can align our technical objectives and technical initiatives to delivering on the business objectives. Maybe, we want to focus in on accelerating delivery because our deployment processes are manual, error prone, inconsistent across environments, heavily, a lot of changes within each release, a lot of changes in different environments. Maybe we want to improve our testing efficiency. And maybe, to start off, because the feasibility of deployment automation or continuous delivery is relatively easy, maybe we can run some workshops on aligning for desired outcomes, and then in parallel we could do accelerating delivery. And as we wind down on accelerating delivery, we would then move to improving their test efficiency, because while it is important, there's some skills building. As we move to test automation is software development. We can't forget that. There is still some design component to it. There's still some application coding or recording and modification to it. There's still version control. There's still reporting on it. There's still maintenance. It is software development. So while very important, the effort in building that up may be a bit more of an investment and may take a little longer. But when we map these out, we get a sense of what do we want to do next, what's important to the business, and how are we contributing to the business objectives. And as I mentioned, and as the conference host, and I want to thank them for letting me do this, I gave you the steps in doing a value stream mapping and moving to a value stream management approach to software development, so that you don't just jump into buying an automation tool and trying to automate a process that may be full of waste. But if you look at the URL at the top of this page, you can also click on this and would be more than happy to meet with your organization and host that collaborative session where we can help you through that process of mapping the value stream at a macro level and providing some guidance based on our experience on where you may want to focus your attention. And with that, I think we got a few minutes left, but is there any questions that have come in from the audience?
Oh, thank you, Al. It was very interesting and complete instruction about fixing bad process, but there was so much information that I didn't put everything in my head. But there are not many questions from the audience. I'll answer it you in the order. Wait a second. Question number 1. I think Einstein ideas are really great to apply to DevOps processes, but didn't have a chance to test that out. Did you have any experience with that, or maybe were observed for his other concepts besides costs of delay?
So let me repeat what I heard. I shared a lot of ideas, and they've experimented with a lot of ideas, but they haven't had a chance to test it out. So what are some of my experiences with respect to the cost of delay? Is that?
Yes, I think that's the question. Yes.
Okay. So I recently moved to HCL Software. Prior to my employment with HCL, I was with IBM, and the cost of delay when we're talking about continuous delivery, which is where I spent a lot of my time on the IBM side. We had a number of clients that were challenged with manual error-prone build scripts, and by that I mean, there was different context in each environment. There was different sign-offs. There was approval processes that had to happen. There was lots of issues, artificial delays, I'm going to call them, things that didn't need to happen as I was waiting to update my scripts because I needed to get some information or I needed to get sign off from a stakeholder. And what we saw from customers in this space was 95% improvement, taking deployment or the release cycle that was quarterly every 3 months down to every 2 weeks or every week. And what was more important is their deployment counts were up, but their deployment failures were down. So there was a higher level of accuracy. Yeah.
Okay, so sorry for interrupting you, but the question was about Randstad. Timur, who asked this question, asked me to say you that the question was about Randstad ideas.
I don't understand the arena.
Okay. Sorry, but Timur, we didn't understand your question. Please.
Yeah, if you send me an email, I'll respond to it.
Okay. So let's go forward. What do you do when you have some features originating not from product business but from developers, like refactoring? Have several VSM boards per feature type or skip fields in this board or something else?
So if you're going to do refactoring or address some sort of a technical debt, it has to be built into the plan, and that may be part of that update type of work that enters the system. So work, but you're going to again want to plan that out. Maybe there's a backlog, or in this particular sprint, we are going to address these types of work activities that have been classified as updates, and then communicate that back to the business. And what's really important is sharing with them that this investment will help you move faster later. One of the things that we may say to organizations when their technical debt or their desire to refactor applications is quite large, is you may have to slow down to speed up. You may have to address things like this on an initiative and do a feature freeze to focus in on these activities as part of a sprint before you move on. Would you capture them as work items? I would, because it's part of the process, and it would help you with prioritization, and it would help you with estimation. It would also help with focus, because it would truly understand, if you do stuff ad hoc, or, hey, I'm working in this module and I think I can write it better. Well, you may be exceeding the time allotment for that task that's associated with it, and then there's no record. So I came from version control, and I'm a change management purist, meaning that unless I was told to do that, I'm not going to rewrite something because I think I can do it better. It exceeds the scope of my ask, but I could submit a ticket to say, there's an opportunity here for improvement, and this is something we should revisit later on. But if you just do work ad hoc without measuring it, you may be negatively impacting some of the measurements that decisions are being made on. So it's good to have a record of it.
Okay, thank you. And El, can you please show where can we send more questions, because the next question is large, and I think I will not be able to send the idea by my voice.
Okay, so on the screen right now, if the moderator will.
Техник, пожалуйста, вы видите на экран текущий слайд Элла? Yes, спасибо.
So if you've got my Twitter handle there, you can follow me on Twitter. The other option is Allan.Wagner, so ALLAN .WAGNER @HCL.com. That's my email address.
Okay, El, thank you very much. This was quite very interesting, and I think that bad processes cannot be fixed by automation. It can be become worse by automation. If you will automate bad process, you will make it worse.
Okay. But you wouldn't make it worse, but you're not going to achieve the value that you hoped in automating. So,
yes, thank you very much, and we'll move forward. And thank you again.